Fuels. Definition. Chemical fuel is a combustible substance containing carbon as main constituent, which on burning in air gives large amount of heat which can be used economically for domestic industrial purposes. Examples: wood, charcoal, coal, kerosene, petrol, diesel, producer gas, water gas, and natural gas, etc. During the process of combustion, the atom of carbon and hydrogen combine with oxygen of air, simultaneous liberation of heat at a rapid rate. This energy is liberated due to the arrangement of valency of electrons present in the atoms, resulting in the formation of new compounds like carbon dioxide and water respectively. Classification of fuels. It can be divided into two different types. One is based on the origin. Primary fuel, it is also known as natural fuel. Secondary fuel, it is called derived fuel. According to their physical state, are again subdivided into three different types: solid, liquid, and gaseous. Physical state: solid. A primary fuel examples: wood, peat, coal, and lignite. Secondary fuel: charcoal and coke. Liquid state: primary fuel: crude petroleum. Secondary fuel: petrol, kerosene, diesel, synthetic petrol. Gaseous state: primary fuel: natural gas. Secondary fuel: producer gas, water gas, coal gas, biogas, and LPG. Characteristic of a good fuel: high calorific value. Fuel should possess high calorific value since the amount of heat liberated and temperature attained thereby depend upon the calorific value of the fuel. Moderate ignition temperature. Ignition temperature is the lowest temperature to which the fuel must be preheated so that it starts burning smoothly. Low moisture content. The moisture content of the fuel reduces the heating value and involves in the loss of money because it is paid for at the same rate of fuel. Low content of combustible matter. In case of solid fuel, the ash content should be less and the size should be uniform. Readily available in bulk at low cost. Product of combustion should not be harmful. Combustion should be easily controllable. It should be safe, convenient, and economical for storage and transport. Calorific value. It is defined as the amount of heat liberated when unit mass burnt in air or oxygen. Units of calorific value. Solid or liquid fuel mentioned in terms of calories per gram or kilocalories per kilogram or joule per kilogram. Gaseous fuels expressed in terms of kilocalories per meter cube or joule per meter cube. Gross or higher calorific value. It is defined as the amount of heat liberated when unit mass per volume of the fuel is burnt completely in air and the product of combustion are cooled to room temperature. Net or low calorific value. It is defined as the amount of heat produced when unit mass per U volume of fuel is completely burnt in air and the product of combustion are allowed to escape into the atmosphere. So GCV is equal to NCV plus latent heat of condensation of steam. Net calorific value is equal to gross calorific value minus 9 into mass of hydrogen into latent heat of steam. Net calorific value is equal to gross calorific value minus 0.09 into percentage of hydrogen into latent heat of steam. Solid fuels. Coal is a highly carbonaceous matter that has been formed as a result of alteration of vegetable matter under certain formation favorable condition. It mainly composed of carbon, hydrogen, nitrogen and oxygen besides non-combustible inorganic matter. Wood first converted into peat, peat converted into lignite, lignite converted into bituminous coal, And the last stage is anthracite. The carbon content of the calorific value and hardness is increases from wood to anthracite. Moisture content, carbon, oxygen, nitrogen, and sulfur content, and also the volatile matter is increases from wood to the anthracite side. Analysis of coal and its significance. The approximate analysis involves the determination of moisture, volatile matter, ash, and fixed carbon. This gives quick and valuable information regarding commercial classification and determination of suitably for a particular industrial use. The ultimate analysis involves the determination of carbon, hydrogen, sulfur, nitrogen, oxygen, and ash. The ultimate analysis is essential for calculating heat balances in any process for which coal is employed as a fuel. Liquid fuels. Petroleum. An important primary liquid fuel is a dark colored viscous oil found deep in the earth crust. It is believed to have been formed millions of years ago by anaerobic decay of marine plant and animal life under the influence of high temperature and pressure. It is mainly a complex mixture of hydrocarbon, a chain paraffin, cycloparaffin, olefin, and aromatics with small amount of other organic compound containing nitrogen, oxygen, and sulfur and traces of inorganic compounds. The average composition of crude oil is carbon 83 to 87%, hydrogen 11 to 15%, sulfur and nitrogen are 0.1 to 5%. Petroleum refining. It is a process of separation of crude oil into different useful fraction on the basis of their boiling points. The crude oil freed from water and sulfur is first converted into preheater. The vapors are then fed into the specially designed large bubble cap fractionating column. The volatile components condense on the upper plate of the fractionating column while the less volatile fraction is collected on the lower plates. The various fraction condensed and collected at different height of the columns or gases: petroleum ether, gasoline or petrol, naphtha, kerosene, diesel or fuel oil or light gas, heavy oil, and paraffin or asphaltic. Cracking. The objective of cracking is to obtain greater yield of improved gasoline by thermal decomposition of the salt's heavier fractions. Gasoline obtained by cracking give a better engine performance than straight run gasoline. Cracking is defined as a process of decomposition of high molecular weight hydrocarbon into low molecular weight hydrocarbon. Cracking process involves breaking of carbon-carbon and carbon-hydrogen bonds. It produces low boiling alkane and alkene. A small amount of carbon and hydrogen are also produced. There are two different types of cracking: thermal cracking and catalytic cracking. Advantage of catalytic cracking: the octane number of gasoline produced is very high. The yield of gasoline is also very high. The process can be better controlled. The product contains a very little amount of undesirable sulfur. There is a saving in production cost since high temperature and high pressure are not needed. In catalytic cracking, external fuel is not required. The necessary heat is obtained by burning of the coke deposited on the catalyst itself during the regeneration process. The gasoline formed contains much less gun and gum forming compounds. Catalysts are selective in their action and therefore they permit cracking of only high boiling hydrocarbon. Gaseous fuels, liquid petroleum gas. It is obtained as a high byproduct during the cracking of heavy oils or from natural gas. LPG is dehydrated, desulfurized, and traces of odorous organic sulfides. It has a calorific value about 25,000 kilocalories per meter cube. LPG consists of hydrocarbon of such volatility that can be exist as gas under atmospheric pressure but can be readily liquefied under pressure. The main constituent of LPG are in butane, isobutane, butylene, and propane. LPG is widely used as a domestic fuel, used as an alternative fuel for IC engine since it permits the alternate of high compression ratios without producing knocking. Advantages of LPG over gasoline as a motor fuel: it's very cheaper than gasoline, it readily mixes with air, it highly knock resistant, reduce residue and oil contaminations less as it burns cleanly. Disadvantage of LPG over gasoline as a mode of fuel. Handling has to be done under pressure. LPG is advantageous only in engine under high compression ratio. Its octane number is very low. Its response to blending is very poor. Water gas. It is essentially a mixture of combustible gases, carbon monoxide and hydrogen. It's also known as blue gas because it burns with a blue flame due to the combustion of carbon monoxide. The calorific value of water gas is about 10,000 to 11,000 kilojoule per meter cube. The average composition of water gas is carbon monoxide 40 to 45 percentage, hydrogen 45 to 50 percentage, carbon monoxide 4 percentage, and nitrogen 4 percentage. Uses of the water gas. It is used for the production of hydrogen. It's extremely used for the manufacture of methyl alcohol. It is used as a fuel in glass and ceramic industries. Enriched water gas, which burns with a luminous flame, is used as an illuminating agent. Producer gas. Producer gas. It is essentially a mix of carbon monoxide and nitrogen. It is prepared by passing air mixed with a little over a red hot coal or coke bed contained at about 1100 degrees Celsius. The calorific value of the producer gas is 4000 to 5000 kilojoule per meter cube, and the reactions that takes place in different zones of the fuel bed. The uses of the producer gases are: it is used as a fuel in the manufacture of steel, glass, coal gas, etc. It is used as a reducing agent in metallurgical operations. Thank you.